Are you taking any late work?
Thank you, Mr. Smedberg.
By the way, Mrs. Bliss really likes your sign.
What's not to like? Okay. Now, if we carry out this reaction, we just put all of these things together in a flask, can we capture any useful energy from it? Not really. The electrons move around and shift from one place to another, but we can't really harness that energy in any way. Now, if we could do this in such a way that we could make the electrons do something for us before they get to their destination, we could capture some electrical energy. We can't do that by putting both of these together in the same container. So what we do is we build a specialized container where each half reaction takes place separately. And they're connected by a wire that the electrons can flow through. We can hook that wire to some kind of device that requires electricity. And you may recall from previous discussions that electricity is just the movement of electrons. By doing that, we can capture electrical energy from this reaction. Okay? So here's what we could do. Let's begin with a couple of jars. Beakers, maybe. Okay? There's a couple of beakers. Maybe pull this down just a bit. Okay. In one beaker, well, in both beakers we're going to put solution of some kind. Okay? And in one beaker, we are going to have and I really should draw that a little farther over. Let me redo that. Let's draw it over here. Okay? We have over here some kind of conductive material. Probably metallic. Okay? And depending on what we have in the solution, it may even determine what kind of metal is best for that. We're going to put a similar one over here. In this one. Okay? Then what we will do, well, yeah, we do need to connect the two things, don't we? So what we're going to do is we're going to attach a wire between these two things. So what we're looking at is two electrodes attached with a wire. Okay? Now, in one side, we're going to have this one, for example. We're going to identify this as the reaction where Pb goes to PbSO4. This one is going to be the one where PbO2 goes to PbSO4. Ah, where's the H2SO4? In both of them in solution. Okay? So, let's identify that. All right. Now, we have 1/2 reaction going on in each half of this container here. One going on in that beaker, one going on in this beaker. Which is which? Which of these reactions is the oxidation reaction? Which one is the reduction reaction?
They don't want it.
One on the left?
Isn't that the oxidation? Yeah.
Yes, this one is the oxidation. Okay? Good.
The red ox.
So this is oxidation. What has to be going on over here? Reduction. Okay? That's true. It is. Now, think back on the definitions of oxidation and reduction. One of these two reactions is going to produce electrons. One of them is going to consume electrons. Which is which? Reduction produces electrons.
Reduction consumes electrons.
Reduction consumes electrons. Well, it's got to be one of them, doesn't it?
Reduction does
Let's think about it in terms of this one. Let's just look at this. This one, we have lead at a 0 becoming lead plus 2.
Forgot what that's the oxidation.
That also means that 2 electrons are being produced, isn't it? Okay? So,
Juggernaut.
electrons produced. This one we have lead at a plus 4 being reduced down to lead at a plus 2. This means that electrons are consumed over here. Okay?
Oil.
Oil rig. Oxidation involves loss, production of electrons. Reduction involves gain or consumption of electrons. Okay, so if we were to label this wire up here as electron flow, which direction would the electrons be going? From oxidation side to reduction side. Okay? Okay. So, we get this all put together here. We have our two separate sides. Electrons produced over here, electrons consumed over there.
So would the reduction side be like the positive side on a battery? Like don't circuits close negative to positive?
Well, if electrons are produced over here, what kind of charge will this inherently have?
Negative.
Okay. Okay? So, we hook this system up just like this. We hook a meter to it. We dip it in. And we see no electron flow after about a second. Why not? Electrons flow for just a brief moment and then they stop. Why is it?
Push the wire out.
No, why? Everything's still hooked up.
There's a break. You run out of what?
Say it again.
Break in the circuit.
There's a break in the circuit.
You just said everything was still hooked up.
We don't, yeah, there is. But we have electrons going from here to here, and then they stop.
Oh, yeah. I thought you meant they stopped.
So, once they get over there, as it is set up right now, we can get a certain number of electrons here, they flow through the wire, they come over here. Now this side has excess electrons. How likely is it to accept more electrons? It's not, unless we can do something else to balance it out. So there's one other component that is necessary to make this work.